Hey, what's up guys? Hope you're doing well. I'm Arvind from Precision Data Science. Today we're going to be working on Amazon review data sentiment analysis. In this dataset, we have features related to Amazon products, and we're going to be building a machine learning model to predict the sentiment of the customer ratings. So without further ado, let's dive into the video. First, we're going to ignore the warnings to have a cleaner output, and then import necessary libraries such as NumPy and Pandas to work on the array data and data frame. Next, we have Matplotlib and Seaborn for data visualizations. We'll read the CSV file review data using read_CSV method and assign it to a data frame df. We'll display the first few rows of the dataset using head method. And here we can see the features such as ID, date added, date updated, brand, name, review rating, review text, etc. for each product purchase. Since we are interested in sentiment analysis, we can skip all of the features and keep only review text and review ratings column. Next, with df.head method, we can see the first 5 review comments and corresponding ratings. We can check the first review comment, and here we can see that the comment is not positive and also the rating is 3. df.shape method shows the number of rows and columns, and we have 5000 rows representing each product purchase and 2 columns representing rating and the review comment. With isnl.sum method, we're going to see the number of missing values in each column. As you can see, there is no missing data in the data frame. For machine learning model to work, we need to convert the review text into numbers, that is tokenization plus vectorization. And for that, first we're gonna import RE module for regular expression and string module for string operations. We're gonna create a function textClean to tidy up our text data before feeding it into our machine learning model. We'll start by converting the text to lowercase to ensure consistency. Then, using regular expression, we'll remove the square brackets, punctuation mark, alphanumeric characters with digits, quotes, double quotes, etc. and then apply this function using a lambda expression named clean. We are applying the textClean function to clean up the review text column in our data frame. After displaying, we can see that the text has been cleaned. Next, we'll remove the stop words by importing stop words from the NLTK library. Stop words are nothing but the words such as the, is, and that we often want to remove from our text data. Next, we define a nifty function, cleanReview. It's like a filter that removes the stop words from our reviews, and we'll apply this function to each row in the review text column. We'll run the valueCounts method on the ratings column, and we can see that the majority of the ratings are 4 and 5. Using log method, we can categorize all the ratings above 3 as 1, representing positive reviews, and rest as 0, representing negative reviews. Again, with valueCounts, we can see that we have more positive reviews than negative reviews. We'll check the first 5 rows again to confirm that the data frame is transformed. As we can see, we had ratings 3, 4, 5, and now it's been converted to 0 and 1, representing negative and positive sentiment. Next, we'll create a word cloud, which is just a visual representation of the text data, where the size of each word indicates its frequency or the importance within the given text. We'll create a function by first filtering the reviews based on sentiment, and then combine all the review text based on sentiment to generate the word cloud. We'll generate the word cloud for both positive and negative reviews, that is 0 and 1 separately. For positive reviews, we have important words like love, Alexa, use, one, great, tablet, etc. And for negative sentiment, we have words such as Amazon, tablet, time, work, app, use, etc. After tokenization, we will use the TF-IDF vectorizer to vectorize the tokenized data that we cleaned from the original review text. We'll instantiate the TF-IDF vectorizer with 10,000 features and fit transform the review text into array. We will assign the transform data to a variable X and then review ratings column to variable Y. Here X acts as a feature column and Y acts as a target column. We're going to import the train test split from the scikit-learn library and split the data into training and test set with a test size as 20% and a random state to maintain consistency. With y-train value counts, we can see the imbalance in the training data, and for this we need to import SMOTE technique from the IMB Learn library. We'll instantiate the SMOTE object with a random state and fit resample for the training data. After resampling, we can see that the data has been balanced. Now let's shift gears to machine learning model implementation. Here we are using a logistic regression which uses sigmoid function to predict the probabilities for each class. We'll instantiate the logistic regression model with a random state 7831 and fit for the training data. After fitting, now let's predict for the test data and assign it to a variable ypred. For evaluation, we're going to import certain metrics such as accuracy, F1 score, classification report, and confusion metrics. We'll plot the classification report along with accuracy and F1 score. As it turns out, we have good precision, recall, and F1 score, and the accuracy is around 96% with F1 score around 81%. Now let's plot the heat map for the confusion matrix to see the comparison of actual versus predicted label. Here we can see that roughly 96% of all review comments have been predicted correctly, and majority of the correct predictions belong to positive class, as we have seen in the dataset. Next, we have 20 review comments which are classified as false positive and 24 review comments classified as false negative. This is expected for a machine learning model, as we have seen the same words being repeated in the word clouds for positive and negative reviews. Next, we'll try to predict the sentiment for a random review comment. Here we are choosing a random index 68 and extracting the features to a variable random data point. We'll make the predictions and compare the predicted value with actual value. As you can see, we have correct predictions for the random positive class. Now let's try with another random index 86, and again we have correct predictions for the random negative class. Now as a bonus, let's try to enter a manual review and see if it makes correct predictions. Just like before, we'll define a function to tokenize the reviewed text and then make prediction for the vectorized input data. We'll type this is good, and we can see that it's a positive review. Now let's try with another example for a negative review. This is not okay. And again we have a correct prediction, that is negative. It's good to see that the machine learning model has been making precise predictions, and you guys can try out this project as a prerequisite for natural language processing. So that's all I have today, guys. If you enjoyed this video so far, please like the video, subscribe, and hit the bell icon to see more content. Thank you.